For this problem, we're asked to determine a definite integral that represents the arc length of the polar curve r equals 9e to the theta, where theta ranges from 0 to 5. We actually are not going to have to evaluate this integral, we simply need to set it up. To assist us, we refer to the theorem in the OpenStax online calculus textbook that states that the arc length of a curve defined by a polar function is the integral from alpha to beta of the square root of the quantity r squared plus derivative of r with respect to theta squared, quantity closed, all taken with respect to theta. This is provided that our polar curve, r equals f of theta, is a function whose derivative is continuous on the interval from alpha to beta. But I want to key in on this last piece right here. Notice to get the arc length of a curve, a polar curve, what we need is two pieces. The value r, or the function r, and dr d theta, which is the first derivative of r with respect to theta. Once we have those two pieces, then we put them into that formula and we add in our limits of integration and we're good to go. So let's go ahead and let's do some calculations. R is just the function 9e to the theta. Dr d theta, well, that's the derivative of r with respect to theta, and that's also 9e to the theta. And so it just looks like we're putting 9e to the theta, squaring it, adding to it 9e to the theta squared again. Let me simplify that really fast. That means we're going to take the integral from 0 to 5 of 9e to the theta squared plus 9e to the theta squared d theta. And if I want to do a little bit of simplifying, I can rewrite 9e to the theta squared as just 81e to the 2 theta. But I have two of those quantities being added up. And so really my integral is simply the integral from 0 to 5 of two of those. So what's that going to be? The square root of 162e to the 2 theta d theta. And if I want to go one more step and simplify, I could take the square root of 162 and rewrite it. The square root of 162 is just 9 times the square root of 2. And then the square root of e to the 2 theta, well, that's just e to the theta. And so my integral really could come down to 9 times the square root of 2 e to the theta d theta. And that's what we could put as our setup for our definite integral. I'm sure the first one would work just as nicely. However, I just like to make it nice and clean here with one expression. So hope this makes sense. If you have any questions, don't hesitate to reach out.